Hello dear students, welcome to a new session. In this session, we will be learning the topic some applications of trigonometry or heights and distances. Now this topic doesn't really have a lot of huge concepts. All we have to do is learn some terminologies and apply them while solving problems. So the first terminology is called line of sight. Now line of sight, as the name suggests, is the line that connects the eye of an observer to the object that he or she is observing. So that is line of sight. Now the second terminology is angle of elevation. Angle of elevation is the angle that is being made between the line of sight and the horizontal while a person is looking something above him or her, as in above the horizontal. So for example, I am looking at an object on the roof and I am looking. So my line of sight will be like this, and this is the horizontal line. Angle of elevation will be made between this line of sight and horizontal. I hope I am clear. The next very important terminology is angle of depression. Like similar to angle of elevation, angle of depression is also formed between the line of sight and the horizontal, but there is a difference. There is a word depression. Depression means down or below. So imagine I am looking at an object below myself or my eye level. So my line of sight will go like this and the horizontal line will be like this. So depression, angle of depression is formed between these two arms. I hope you understand the difference between angle of elevation and angle of depression. Before moving on to the numericals, let's revise the trigonometric ratios of specific angles, namely 30 degree, 45 degree and 60 degree. Now have a look at the table that is being shown. There are sine, cos and tan of 30, 60 and 45 degrees given. So sine 30 degree is 1 by 2. Cos 30 degree is root 3 by 2 and tan 30 degree is 1 by root 3. Now moving on to 45 degree, sine 45 degree is 1 by root 2, so is cos 45 degree and tan 45 degree is 1. Now sine 60 is equal to root 3 by 2, cos 60 is equal to 1 by 2 and tan 60 is equal to root 3 by 2. Root 3, sorry. That's it. That's all about the concept. Now let's start applying these concepts into equations or numerical problems. So the first type of problems that we are going to do is very short answer type questions of 1 mark each. Let's have a look at the first question. A ladder 15-meter long just reaches the top of a vertical wall. If the ladder makes an angle of 60 degree with the wall, then calculate the height of the wall. That's it, right? So in this chapter or in this entire chapter, while doing the problems, we have to equally concentrate with the figures as well as the numericals, as well as the arithmetic part. As in, figures are equally important. So you have to really practice drawing the figure by assessing the question. Now from this question, there is a vertical wall to begin with. So in the figure shown on the extreme right side of the screen, you can see the vertical wall BC, that is vertical, which means BC is making an angle 90 degree with respect to the horizontal represented by the line AB. I hope that's clear. Now the question says that a ladder is being placed, is inclined to the wall. So the ladder is being represented by the line AC on this figure. And the length of the ladder is given 15 meter. So that's the data we need. One more thing, the ladder is making an angle 60 degree with the vertical wall. Okay, now don't get confused this angle 60 degree with angle of elevation or depression. Angle of elevation or depression is formed only with line of sight and a horizontal component. I repeat, only line of sight and a horizontal component can form angle of elevation or depression. Well, in this question, the vertical component is forming the angle. So this is neither angle of depression nor angle of elevation. You always make a note of that. This is just an angle in the triangle. So in triangle ABC, C is equal to 60 degree and B is equal to 90 degree. So we can find the measure of angle A using angle sum property. So angle A will be obtained, or the measure of angle A will be 30 degree. Now we are supposed to find the height of the wall, that is BC. So we need height and we only have the hypotenuse of the triangle, or we only have the side opposite to the 30 degree angle and the hypotenuse. Now which is the trigonometric ratio that connects the opposite side to the hypotenuse? That's right, sine. So we take sine 30 is equal to BC by AC, or what is sine 30? Sine 30 is equal to 1 by 2. So 1 by 2 is equal to BC, let it be BC, or you can take it as H, whatever you want. So let it be BC by 15, that is the length of the ladder. Now upon cancellation and cross multiplication, we will get the value of BC, or the height of the wall, as 15 by 2 meter or 7.5 meter. We shall move to the next question now. In the given figure, a tower AB is 20 meter high and BC, its shadow on the ground, is 20 root 3 meter long. Find the angle theta. So you may refer the figure given. So in triangle ABC, tan theta is equal to 20 by 20 root 3, as an opposite by adjacent side. Upon cancelling the 20 on numerator and denominator, we will get 1 by root 3. That means tan theta is equal to 1 by root 3. Now tan of which angle is 1 by root 3? So that angle will be theta. So tan 30 is 1 by root 3. So therefore theta is equal to 30 degree. That's how we find it. Next question. In the figure, AB is a 6 meter high pole and CD is a ladder inclined at an angle of 60 degree to the horizontal and reaches up to a point D of pole. If the AD is equal to 2.54 meter, find the length of the ladder. Use root 3 is equal to 1.73. Again, you can refer the figure given on the extreme right side. You can see a pole 6 meter tall and a ladder inclined like CD position. So the line CD is the ladder. Now we are supposed to find the length of ladder. That means the hypotenuse is what we want. Also the gap between A and D, AD is equal to 2.54, and the angle the ladder is making with respect to the ground is 60 degree. Now we have to find DC. So DC and DB are the components that we take. So in triangle DBC, sine 60 is equal to DB by CD. Now DB can be found by subtracting 2.54 from 6. So 6 minus 2.54 by CD is equal to sine 60 is equal to root 3 by 2. So root 3 by 2 is equal to 3.46 by CD, or CD is equal to 4 meter. Moving on to the next question. The tops of two towers of height X and Y standing on level ground subtend angles of 30 degree and 60 degree respectively at the center of the line joining their feet. Then find X is to Y. So we are supposed to find the ratio of heights of two towers. So in the figure, let AB be X, or the first tower with height X, and CD be the tower 2 with height Y. And they have specifically said that they are standing on level ground. So angle B and angle D will be 90 degree. Now they are subtending angles 30 degree and 60 degree at the center of the line joining their feet. So if they are standing like this, then the line joining their feet is BD, and let C be the center of BD. Then the top of the first tower, that is A, is subtending angle 60 degree, and the top of the second tower, that is E, that is subtending angle 30 degree at C. So this is how the figure would look like. And the important thing that we have to remember is that C is the midpoint of BD. So we can take BC and CD as some variable. I am taking P here. So we get two right triangles. Let's take the first right triangle. In right triangle ABC, tan 60 is equal to AB by BC. That is equal to x by P. Now tan 60 is equal to root 3. So root 3 is equal to x by P, or x is equal to P root 3. Now moving on to the next triangle. In triangle EDC, that is 30 degrees. So tan 30 is equal to ED by DC is equal to y by P. Now tan 30 is 1 by root 3. So the equation will be 1 by root 3 is equal to y by P, or y is equal to P by root 3. Now it's easy. All we have to do is find x is to y. So x is to y is equal to, upon cancelling the common and multiplying root 3 and root 3, we will get 3, or the ratio is 3 is to 1. Next question. An observer 1.7 meter tall is 20 root 3 meter away from a tower. The angle of elevation from the eye of observer to the top of the tower is 30 degrees. Find height of the tower. Again, figure is not given. So let's start from the level ground, that let it be BC, and we have to draw the person's height because they had specifically given the height of the person. So let's draw AB as 1.7 meter, and from the person he is looking at a tower, say DC, with a height h, and we are supposed to find h. So let DC be h and let E be a point on DC such that EC is equal to AB. Both are 1.7 meter. Again, another data is that the person is 20 root 3 meter away from the tower. So BC or AE will be 20 root 3 meter. Now the angle of elevation is given as 30 degrees. So angle A or angle DAE is 30 degrees. Simple. Now let's take triangle AED. Tan 30 is equal to DE by AE. How do you find DE? Subtracting 1.7 minus by from h. So 1 by root 3, that is tan 30, will be equal to h minus 1.7 by 20 root 3. Upon cross multiplication and transposing, we will get h or height of the tower as 21.7 meter. Now let's move on to the second type of questions. Short answer type questions carrying 2 marks each. The first question. The angles of depression of two ships from the top of a lighthouse and on the same side of it are found to be 45 and 30 degrees. If the ships are 200 meter apart, find height of the lighthouse. That's the question. Again, the figure is not given, so we have to start from the level ground. And the angles of depressions of two ships from a lighthouse. So lighthouse be the vertical factor. So let it be AB with the height h. We have to find height of the lighthouse. Now there are two ships. So we have to draw a line BD with respect to the ground and spot 2 points. Let D be the position of one ship and C be the position of the other one. Now you may join both C and D to A because we have to form the angles of depression. Now remember the definition of angle of depression. It is formed between the line of sight and the horizontal component. So angle A with respect to D is 30 degree and angle A with respect to C is 45 degree. Another interesting fact or relation between angles of elevation and depression in a single case is that they are alternate interior angles. So we can say that angle ADB is equal to 30 degree and angle ACB is equal to 45 degree. then the space between the ships is 200 meter. They have specified it in the question. If the ships are 200 meters apart, which means DC is equal to 200 meter, and we don't know how far is the ship at the position C from the lighthouse. So let that distance CD be P. So we have height H, CD as P and DC as 200. So we have again two right triangles. So in triangle ABC, tan 45 degree is equal to AB by BC. AB is H and BC is P. Tan 45 is 1. We will get P is equal to H. Let it be there. Now in the next triangle, triangle ABD, tan 30 degree is equal to AB by BD. Now AB is H again and BD is now 200 plus P. So 1 by root 3, that is tan 30, is equal to H by P plus 200. Again cross multiplied, we will get H plus 200 is equal to root 3H. Cancelling each other and rationalizing the denominator, we will get the final answer for H as 273 meters. Next question. The horizontal distance between two poles is 15 meter. The angles of depression of the top of the first pole as seen from the top of the second pole is 30 degree. If the height of the second pole is 24 meter, find height of the first pole. Use root 3 is equal to 1.732. So let's draw the figure. AB will be the first pole. Let EC be the second pole. And the angle of depression from E to A is given as 30 degree. So that will be equal with the alternate interior angle. So angle A will be inside will be 30 degree with respect to the horizontal line. So let's join the horizontal line AD. So angle EAD is now 30 degree. And the distance between the poles was given to be 15 meter, the horizontal distance. So BC or AD will be 15 meter each. Now we will take the triangle ADE. In that, tan 30 degree will be equal to ED by AD. Now ED is equal to 24 minus H. We have taken the height of the first pole as H. So 24 minus H by 15 will be equal to tan 30, that is equal to 1 by root 3. Now upon cancellation and solving, we will get the value of H as 15.34 meter. We have rounded the value. It was ideally 15.33 something. So we can round it to 15.34 meter. Always use the value of root 3 if it's specified in the question. Moving on to the next question. Two ships are there in the sea on either sides of a lighthouse in such a way that the ships and the lighthouse are in the same straight line. The angles of depression of two ships as observed from the top of the lighthouse are 60 degree and 45 degree. If the height of the lighthouse is 200 meter, find the distance between the two ships. So there is a lighthouse 200 meter tall and there are two ships on either sides of the lighthouse. We are supposed to find the distance between the two ships. So let AB be the the lighthouse, and C be the position of one ship and D be the position of the other one. And the angle of depression from A to C is 45 degree. So the angle C inside the triangle will be 45 degree. So the angle of D will be angle of depression from A to D is 60 degree. So angle D inside will be 60 degree. So we will get two right triangles. In the first right triangle ABC, and tan 45 is equal to AB by BC. And one more thing, we have taken the distance BC as X and distance BD as Y. So the total distance between the ships would be X plus Y together. So to find x, we are using the first triangle. So in triangle ABC, x is equal to 200 meter. In the next triangle ABD, tan 60 is equal to AB by BD, or root 3 is equal to AB is the height, that is 200 meter, by y. Now we will get y is equal to 200 by root 3. Now whenever we are not given the value of root 3 is equal to 1.73 or something, we have to use root 3 itself, and here you can see the value of y is 200 by 3. You have to rationalize the denominator. Then we will get 200 root 3 by 3 meter. Now the distance, for the distance we can combine x and y, which means we have to add them, and we have added them here, and we have substituted for the value of root 3 as 1.73 as given in the question. So the final answer, that is the distance between the ships, is 315.33 meter. Moving on to the next question. The angle of elevation of an airplane from a point on the ground is 60 degree. After a flight of 30 seconds, the angle of elevation becomes 30 degree. If the airplane is flying at a constant height of 3000 root 3 meter, find speed of the airplane. So a person is standing at a fixed point, let that point be A. Now let the initial position of the flight be C. So the height of the flight is BC, and that is 3000 root 3 meter. Now after 30 seconds, the flight has traveled certain distance by maintaining the same height. So let that, the new position after 30 seconds, be E, and the distance will be ED. And the height is not changing, so ED will be equal to CB, 3000 root 3 meter itself. Now the angle of elevation in triangle CAD was 60 degree, and the angle of elevation in the next position, or EAD, is equal to 30 degree. Hence we got two triangles again. So in the first triangle, in triangle ABC, tan 60 degree is equal to BC by AB, or root 3 is equal to 3000 root 3 by AB, or AB is equal to 3000 kilometers. In the next triangle, triangle AED, tan 30 is equal to BD by AD. Now tan 30 is 1 by root 3, that is equal to BC by AD, can be splitted into AB plus BD. Then we will get AB plus 30S is equal to BC root 3. Now from the equation of physics, the basic equation regarding distance, speed and time, we know that distance is equal to speed into time. So we have assumed the distance BD as 30, the time taken to travel from B to D as 30, that is 30 seconds, and we have taken the speed as S, so 30S. That's how we got 30S. So 30S plus AB is equal to BC root 3. AB is equal to 3000. We got it from the first triangle, and BC is equal to 3000 root 3, and cancelling or equating, simplifying the equation, we will get S is equal to 200 meter per second. So before beginning with the procedures, we have to first give the assumption, let speed be S, and apply the distance, speed and time equation. Now coming to the next question. From the top of a 60 meter high building, the angles of depression of the top and bottom of a tower are 45 degree and 60 degree respectively. Find height of the tower taking root 3 is equal to 1.73 as a value. Now the building is AC, that is 60 meter tall, and the tower is ED. We are asked to find the height of the tower, so let that height be H. Now BE is equal to CD, and we don't know the gap between them, so let it be BD or CE, BE or CD as well. Now the angles of depression are given. Those will be angle of elevation, alternate interior angles. So in triangle ADC, angle D is equal to 60 degree, and in triangle AEB, angle E will be equal to 45 degree. So we'll take the first triangle, a small triangle. In triangle ABE, tan 45 is equal to AB by BE. Or we can write AB as AC minus BC or 60 minus BC. So tan 45 is 1, which means we can write 60 minus BC is equal to BE. Let's pause it there. Now we'll come to the next triangle. In triangle ACD, tan 60 is equal to AC by CD. Tan 60 is equal to root 3. So 60 by BE is equal to root 3. Upon substitution, we will get the value of BE as 20 root 3. Now 60 minus BC is equal to BE, that is equal to 20 root 3. Then we can simplify it and obtain the value of BC as 25.4 meter. Now BC is same as ED, which is the height of the tower. Therefore height of the tower is equal to 25.4 meter. Let's move on to the next type of questions, long answer type questions of 3 marks each. The first question. The angle of elevation of the top of a building from the foot of a tower is 30 degree, and the angle of elevation of the top of a tower from the foot of the building is 45 degree. If the tower is 30 meter high, find the height of the building. So there is a tower and there is a building. From the top of the either both tower and building, there are angles of elevation going to each other's foots. So we get two right triangles, and let the gap between them be y, and let the height of the building be x. The tower is 30 meter tall, that's been given. Now in triangle ABC, tan 45 is equal to AB by BC, that is equal to 1, and that will be equal to 30 by y. From that we can write y is equal to 30 meter. In the next triangle, triangle DCB, tan 30 degree is equal to DC by BC. 1 by root 3 is equal to x by y. We will get y is equal to x root 3. We already know that y is equal to 30 meter, so we can find the value of x as 10 root 3 meter. Next question. The angle of elevation of an airplane from a point A on the ground is 60 degree. After a flight of 15 seconds, the angle of elevation changes to 30 degree. If the aeroplane is flying at a constant height of 1500 root 3 meter, find speed of the plane in kilometer per hour. So there is a point A on the ground. From that point, an observer is looking at a flight that is 1500 meter high above the ground. Then after 15 seconds, the position of the horizontal position of the flight is being changed to another point, but still the height is the same. Again, so we'll get two triangles. So in the first triangle, the angle of elevation is 60 degree, and in the second triangle, it became 30 degree. So in the triangle ABP, tan 60 is equal to PB by AB. Tan 60 is root 3, so that is equal to PB is the height, so that is 1500 root 3 by x. From that we can get x is equal to 1500 meter. In the next triangle, triangle ACQ, tan 30 is equal to QC by AC. Tan 30 is 1 by root 3, then it's equal to 1500 root 3 by x plus 15s. So we have taken the speed of flight as s. So the distance BC will be speed into time, that is 15 into s. So we can replace the denominator with x plus 15s, because the whole denominator is AC. AC can be written as AB plus BC. AB is x and BC is 15s. I hope you got how we got 15s. I'll repeat, we have taken the speed of light as s and it takes 15 seconds to travel BC. So distance is equal to speed s into time 15. So 15s. So x plus 15s is equal to 1500 root 3 into 3 after cross multiplication. Now we will get the value of s by putting the value of x as 300 minus 100, that is equal to 200 meter per second. Now the question has specifically asked us to find it in kilometer per hour. We know that 1 hour has 3600 seconds and 1 kilometer has 1000 meters. So to convert 200 meter per second to kilometer per hour, the calculation is 200 into 3600 divided by 1000 and we will get 720 kilometer per hour. Next question. A man standing on the deck of a ship which is 10 meter above water level observes the angle of elevation of the top of a hill as 60 degree and the angle of depression of the base of the hill as 30 degree. Find the distance of the hill from the ship and height of the hill. So the man is standing on the deck of a ship 10 meter above water level. So let this be the water level. The man is 10 meter above the water level. Sorry, this is the water level, 10 meter above the water level. And he is looking at the cliff, the top of the cliff. He can see the top of the cliff as well as the bottom of the cliff. So the angle of elevation of the top is 60 degree and angle of depression is 30 degree. So we will get two triangles again. In triangle ABC, tan 30 is equal to AB by BC, 1 by root 3 is equal to 10 by BC, or BC is equal to 10 root 3 meter. Now in triangle ADE, tan 60 is equal to DE by AD. Root 3 is equal to DE by AD is 10 root 3 because AD and BC are the same. So 10 root 3 is the denominator and we will get DE is equal to 30 meter. Now height of the hill is equal to 10 meter plus DE, that is equal to 10 plus 30, total is 40 meter. So the cliff or the hill is 40 meter tall. And the distance between the ship and the hill is given by BC, that we already found. We got it as 10 root 3 meter. Next question. From the top of a tower 100 meter high, a man observes two cars on the opposite side of the tower with angles of depression 30 and 45 degree respectively. Find distance between the car using root 3 is equal to 1.732. So there is a tower in the middle. There are two cars. The man has spotted both the cars and the angles of depression are 30 and 45 degree. So we know that the alternate interior angles will also be equal. So in triangle ABC, tan 45 is equal to AB by BC. 1 is equal to, we know that the tower is 100 meter high. So 1 is equal to 100 by BC, or BC is equal to 100 meter. In the other triangle ABD, tan 30 is equal to AB by BD, or 1 by root 3 which is tan 30 is equal to 100 by BD, or BD is equal to 100 root 3 meter. Now distance between the cars is BC plus BD. So 100 plus 100 root 3 will be the total distance, and the distance the value of root 3 is to be taken as 1.732. So we have to substitute that will become 100 plus 100 into 1.732. 100 is common in both, so we can take that out. So the equation becomes 100 into 1 plus 1.732. That will be 100 into 2.732. So 100 into 2.732 is 273.2 meters. We shall discuss very long answer type questions now. They usually carry 4 or 5 marks. Now the first question, the angle of elevation of a cloud from a point 60 meter above the surface of the water of a lake is 30 degree and the angle of depression of its shadow in water is 60 degree. Find height of the cloud from the surface of the water. So let this be the water level. Let this be the 60 meter height. So a person is standing at a level of 60 meter from the water. Then he is looking at the cloud. And let the height of the cloud be h. Now the person is also looking at the reflection or the shadow of the cloud. Now even though the shadows are seen or the reflections are seen on the surface of the water, we can't really draw a line that is ranging from or a line from the eye of the person to the water surface. The water will act as a plane mirror. One of the properties of reflection by a plane mirror is that the distance of the object in front of the mirror and the distance of the image behind the mirror will be same. So even if the reflection of the cloud is seen on the water surface, the cloud is appear to be coming from below the water. I hope my point is clear. Even though the image of the cloud is seen on the water surface, it actually appear to come from below the water level at the same height as it's above. So if the height is h, then it is appearing to come from a depth h below the water level. So that is the point where we can see the cloud actually. So the eye or the line of sight will be from A to below the water level at a distance h as shown in the figure. So AB is that 60 meter above the ground, above the water level. Then AC is the line of sight to the cloud and CE is the height of the cloud from the water level and EF is height of the image below the water level. So AC and AD are making the 30 degree angle of elevation, and AD and AF are making the angle 60 degree angle of depression. Always remember this point or this concept while doing the clouds problem. Now we shall begin. We have two triangles. So in triangle ADC, tan 30 degree is equal to CD by AD. Tan 30 is equal to 1 by root 3. CD can be written as h minus 60 by, we are taking the distance AD as x. So we will get x is equal to h minus 60 into root 3. Now in the next triangle, tan 60 is equal to FD by AD. FD can be split into DE plus EF in the big triangle. So root 3 is equal to 60 plus h by x. Upon substituting for the value of x, we will get the value of h as 120 meter, which means the cloud is 120 meter above from the surface of water. Now the next question. A bird is sitting on top of a 80 meter high tree. From a point on the ground, the angle of elevation of the bird is 45 degree. The bird flies away horizontally in such a way that it remained at a constant height from the ground. After 2 seconds, the angle of elevation of the bird from the same point is 30 degree. Find speed of flying of the bird. Take root 3 is equal to 1.732. So to begin with, we have to give assumption to the speed of whatever thing that is moving, whether it be flight or helicopter or a bird. So here it's a bird in this case. So let speed of the bird be s or any other variable. And we shall continue with our triangles. So in triangle ABC, tan 45 degree is equal to BC by AB. Tan 45 is 1, so 1 is equal to 80 by y, or y, which is the distance AB, is equal to 80 meter. Now in triangle ADE, tan 30 is equal to ED by AD. ED by AD can be further divided into its constituent parts, that is AB plus DE or X plus Y. Now we already know the value of Y, so we can find the value of X as 58.56 meter. So that's what we have to find. Now the speed is equal to distance by time, the rule of physics. So distance is 58.56 in that gap of 2 seconds. So time is 2. So 58.56 divided by 2 will give you 29.28 meter per second. Moving on to the next question. From a point on the ground, the angles of elevation of the bottom and top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree respectively. Find height of the tower. So I'll repeat it again. From a point on ground. So let this be the point on the ground. So the angles of elevation of bottom and top of a tower fixed at top of a building. So there is a building and the tower is on top of the building. I hope that's clear. There is a 20-meter tall building and the tower is being kept above the building, and the person at this point on the ground is looking at top as well as bottom of the tower, not the building. Okay, so we are supposed to find the height of the tower. So we have taken the height as X. Now in triangle ABD, tan 45 is equal to AB by AD. 1 is equal to AB is the height of the building, that is 20 by AD, or AD is equal to 20 meter. That means a gap between the observer and the building and the tower, whatever. Now in triangle ACD, tan 60 is equal to AC by AD. AC can be written as sum of AB and BC. So AC by AD is equal to AB plus BC by AD. Now that is equal to root 3. Tan 60, root 3. So tan 60 is equal to, what is AB and what is BC? X and 20. So numerator will be X plus 20 divided by 20, or 20 root 3 is equal to X plus 20, or X is equal to transposing like terms to one side and isolating X at one other side. We will get 20 root 3 minus 20. Now we can see that 20 is common in both the terms, so you can take 20 out. So the equation becomes X is equal to 20 into root 3 minus 1. And we are asked to take the value of root 3 as 1.732. So the equation becomes 20 into 1.732 minus 1, that is 0.732. So 20 into 0.732 will give you 14.46 meter. Thank you.